Well, hey everybody, how are we doing? We are slowly trucking our way through this chapter 4, which is all about equations and functions and formalizing relations between our x's and our y's. And now we've learned that, satisfying these certain conditions for things to be a function, like none of your x's are allowed to repeat. As we keep going here, we have to realize that, of course, the more real life applications of these items are when we are actually solving equations that are in the form of word problems. And we have to be able to write these things down, take the written word and turn it into an algebraic form so that we're able to solve for whatever they're wanting us to do. Okay, nothing gets more real life than this. So let's start off with, we need to think of some things as we start to read different word problems. We have to realize that there are words that they clue us to what form of mathematics we're doing, like multiplying. They may say the product of two things. They may use the word times, which is pretty straightforward. Think of some other things, other words that you might be able to come up with. Add this to your list on your particular set of notes. Product, times, those are all great ways that we are looking at. Division, the most common word they'll use is quotient, the quotient of a number and a variable. So quotient something. Now, they may literally use the word divide or different things like that. So think, what can you add to this list on your particular paper? What are other words that you can think of that are synonyms to the word divide? Add, well, we have what? Sum. What is the combination of these two things? What is the sum of these two things? They literally could use the word addition. Subtraction, they could use the word difference. Minus. Less than. Get over here. More than. Or more than someone else. This one has for less than, meaning subtraction. Equals. Is. Totals. Grand total. Think of things. Yeah, there are more that we could add to this. What else can you think of that we can add to this that could help us out along our way? All right. Now, as we start to do some of these things here, we have to realize that we have to be careful. All right. As we go through here, what else can we put up? Subtraction. It's the trickiest of, in my opinion, the trickiest of everything to write. We have to remember this, okay? When they have something like 5, here's the key word again, less than. Just remember, in subtraction, we had less than over here. 5 less than x is y. Is the equals, less than is the minus. But when we go to write that 5 less than, we don't write 5 minus x because we're taking 5 away from something. What are we taking it away from? The x. So the x has to come first. Then we have the minus 5 over here equals y. Again, here's one of these. It's working with the special word quotient. Quotient means division. So the quotient of 3 and x is 5. the quotient of 3 and the number x. So the division of 3 divided by x is y. Again, as we start to write some of these, you pause it. Maybe you try this next example here. So this is example 1, example 2, example 3, example 4. 3 less than the product of 2 and x is y. So again, look, you took the time to stop and try this on your own. Remember, we're taking 3 less than. That means minus 3. So we're taking away 3 from what? From the product. From the product of 2 and x. Product means multiplication. What are we multiplying together? 2 and x. Is means equal. That's an important one. And what does it equal? It all equals y. Again, piece by piece as we're slowly putting these things together. Example 4. Now we're starting to get more of a story with what they want us to do. A plumber's fees, F, are $76 for the house call and $61 per hour. So that tells me again, look at this. We could add something else over here to our multiplication. Per. 61 per hour. So for every hour that passes, $61 is being charged or multiplied. And what? There were a base cost of $76. So that plumber was charging you $76 for the house call and was addition. The plumber's fees are, again, another word we could use over here for equals. The plumber's fees are, or means totals, right? Same thing. So all of this is going to total F. So here's our variables this time. It's an H, comma, and F. Because in this case, H is the independent variable, and F, the price, the total fees, is dependent on how many hours you work. Nice, easy ways to start to write equations here. 2 more. Uber charges $4.25 for the first mile and $1.51 for each additional mile. Write a rule describing the total rate R as a function of miles. What is R of 12? Okay, so they want us to say here, they want us to write this function, R of the rate and with respect to miles. So we start off with what? The Uber charges $4.25 for your first mile, meaning no matter what, you are paying that much first. And $1.51 for each additional mile. So plus 1.51 for each additional mile. So you have your equation, but now they want us to find what is R of 12. What is R of 12? Meaning when our independent variable M is 12, what does R equal? So we have to do the substitution method. They substituted m for 12. We're going to substitute m for 12. We remove our m, and we plug in a 12. Now we start to do some math. So you have $1.51 times 12 miles. This gives us $18. Ooh, I just thought of something here. Look at this. Let's read this again. Again, this is a confusing one, right? Think about this. They want to know what is R of, how they're going to go R total. When miles, your total miles is going to be 12. So what should actually be in here? This is actually leading up to our next lesson. They're tricky, these textbook writers, right? Let's think about this. Your total trip is 12 miles. They said according to our formula, the first mile is 4.25. Each additional mile, right, is $1.51. So if you're going a grand total of 12 miles, how many miles? 1 mile is here. You take away 1, and this is 11. Ooh, they were tricky on this one to us. I almost even messed that one up, all right? So 1.51 times 11 is going to be 16.61. Now we add to that the $4.25 for that first mile. And our Uber trip is going to cost us $20.86. Sneaky, sneaky on this one, right? So our ride, when our total miles is going to be M. There we go. When that total miles M is 12, well, we have 1 additional mile, the first mile here, and then the other 11 get multiplied into here. Be careful on this one. This is tricky. Tricky question. The area of a rectangle whose length is 3 more than its width. What is the area if the width is 2 feet? This is one that we should draw a picture for. Pictures help us. Area. And this is a good question because this is a higher order question, guys. This is, do you first off even remember length times width gives you area? So it says the area of a rectangle whose length is 3 more than its width, and its width was 2 feet, right? The area of a rectangle whose length is 3 more than its width. If its width is 2, 3 more than, so it would be 2 plus 3 is 5. Okay, so we're able to, like, we know that this equals 5. 2 times 5 is 10. That's the area. Okay, well, they would want us to write maybe this equation for it, right? So think about this again. If they didn't give us this, what is the area if the width? So let's write it without the given information. Let's write it with just variables first. Okay, so if, I'll draw another picture so we can see. We know that this is going to be width, right? And the length is 3 more than the width. So W plus 3. And then if we go to actually write the area, the formula, the area equals W times W plus 3, right? We can use the distributive property here. So the area equals, well, W times W is W squared plus 3W. And you're able to take this, as they said here, what if our width was 2? We could take 2 and plug this in, right? 2 squared. Let's see if we get our 10 like we think we should. Plus 3 times, remove the W and put in a 2. So this is what? 2 squared gives us 4. 2 times 3 gives us 6. There we go. We just proved our equation. So here is the algebraic equation that represents this when we have an unknown width. And if they give us a width like 2, we're able to substitute the 2 in, evaluate it, and then be able to determine what that width is. We have to read word problems very carefully, point out the important things in these word problems like more than, the and, the key features like the numbers that we need, the variables, mile, width, is, what is the area? All these things are important as we go through these different word problems, guys, and we start looking at them. We read carefully. These words that we've put in these boxes help us identify these key features that allow us to put things in. 3 less than, minus 3. What is it less than? The product of 2 and x, meaning 2 times x. Is y. All these things, individual little pieces, add up into this class. So if you're doing your homework, you're going to start to see this work actually starts to get easier for you as you keep practicing. All right, get out there, guys, get into your Delta Math, get your homework done. Have a wonderful day.